gradient of a scalar point function. We are going to do examples today. We have to recall some points. First one is, we know that grad phi or del phi is equal to I curly phi by curly x plus j curly phi by curly y plus k curly phi by curly z. Second, if a vector is any unit vector, then its dot product with grad phi is the directional derivative of phi along the direction of a. Now whenever you have to find the directional derivative of the given level surface along the direction of a vector, where a vector is your unit vector, then you need to calculate a vector dot grad phi, where this a vector is unit vector. This is very important. To find the unit of a vector, this is equal to vector over its magnitude. The vector normal to the level surface is grad phi. Now grad phi is the vector normal to the level surface. This I have discussed with you in my previous video, geometrical interpretation of grad phi. Now to find its unit vector normal, because vector normal is grad phi, so its unit vector normal is equal to grad phi over its magnitude. Fifth is, the greatest rate of increase of a scalar function phi at the point alpha, beta, gamma is magnitude of grad phi, its mod at the point alpha, beta, gamma, right? So for greatest rate of increase of scalar function, you have to calculate the magnitude for the grad phi at the given point. Now to start with the examples, first one is, if a and b are the constant vectors, you have to show that a part grad for dot product of r and a is a, and grad of this triple product of the vectors is a cross b. For the first part, we need to just define our r vector as xi plus yj plus zk, and because a and b are the constant vectors, we take a vector to be as a1i plus a2j plus a3k and b vector as b1i plus b2j plus b3k, where a1, a2, a3 and b1, b2, b3 are constants. Then first we calculate this product, the bracket r dot a. So r is given, put the value for r and a. Now the dot product for this. Now dot product for I and I is 1. For j and j is 1, for k and k is 1. But the dot product for I and j, I and k is 0, means different vectors having the dot product as 0. The same vector is having the dot product as 1. So if we take the dot product, the first one, dot product of this, now this will be a1x, because I dot I is 1. Then xi dot with a2j, this will be 0 because I dot j will be 0. And xi with a3k is also 0. So xi with a1i is a1x plus, now for the second term, the dot product of yj with a1i is 0. The dot product of yj with a2j is, yes, a2y, because j dot j is 1. And the dot product of yj with a3k is 0 because j dot k is 0. Similarly for the third term, the dot product for zk with a1i is 0 because k dot I is 0. Dot product of zk with a2j is also 0 because k dot j is 0. And then zk with a3k is a3z because k dot k is 1. Now to take the grad for this r dot a, this is del of r dot a. We know that del operator is I curly by curly x plus j curly by curly y plus k curly by curly z. For this a1x plus a2y plus a3z. Now what is the curly by curly x for whole a1x plus a2y plus a3j? Yes, this will be derived with respect to x. This is a1. Then j, curly by curly y for a1x plus a2y plus a3z is a2. Then curly by curly z for a1x plus a2y plus a3z is, yes, a3. Now this is nothing but your a vector only. Hence, grad of r dot a is a vector. That means whenever I'm having the dot product of a with r and having its gradient, then the answer will be this a vector. Second part, since the triple product it can be written as, just take this as first vector, its dot product with cross product of other two vectors. Right, this is opened as this. Just remember this result. Now taking the grad for this triple product, which is equal to grad for this r dot cross product of a and b, this will be, now see, I'm using the result 1, I'm using the part 1. We know that grad for r dot a is a. So the grad for r dot this will be a cross b. Right? So just take the use of the first part.